In this podcast, I want to take a look at some lab reports and concentrate particularly on how to add the necessary detail to a lab report, a basic lab report, to turn maybe a grade 5 lab report into a grade 7 lab report. So to help me to do that, what I've done is I've taken a lab report, a student's lab report, and I've turned it, if you like, into a grade 5 lab report, and I've also enhanced it to turn it into a 7 lab report. So these two lab reports are very similar, and I'm going to be contrasting the two as we go through. So this lab report was about the potential difference across light bulbs and a resistor, essentially looking at how the resistance of these components changed. So the aim, you can see, is the same on both sides. This one on the left, this is my 5 lab report, and this on the right is my 7. So to investigate the relationship between the current through and potential difference across a bulb and a resistor, both the same. Now the hypotheses, you can see there's a difference here. In the basic hypothesis, I believe the data will follow Ohm's law and that therefore the graph will be a straight line graph. So this one's a little bit lacking. There's no mention of whether the writer is talking about the bulb or the resistor in this case. So we want to highlight that and be a little bit more specific. I believe the data for the resistor will follow Ohm's law. The data for the resistor will follow Ohm's law, and it will see that the PD is proportional to the current. For the bulb, the data will not produce a straight line as Ohm's law is not obeyed. I think this is because the bulb will get very hot and the resistor will not. So there's a lot more detail there. There's some reasons. I think this is because is a very good word to include in a hypothesis. It's showing that you're thinking about the reasons behind your suggestion for the outcome, your hypothesis. Variables. Now essentially the variables are similar here. The independent variable is the current in this one. I've just been a little bit more specific and said the current through the component. Potential difference, a little bit more specific. And in terms of the controlled variables, again, it's pretty similar there. The method, also pretty similar. The method looks short, but it's long enough, it's detailed enough to actually get the point across. You can see here that I've included the units, made sure that the units here are included. They're not included here. Also, one thing that's omitted from the 5 lab report is a circuit diagram, which has been included over here. So a circuit diagram is important to show exactly what was done. Let's take a look at that circuit diagram. So there's the circuit diagram, and as I said, it's not included in the other example over here. The student goes straight through into the results. So the circuit diagram, it's a basic one, but ammeter, voltmeter, resistor, power supply, these things are annotated, so it shows clearly how the circuit was set up. Let's move on to the data tables. So here's the data tables here and here. So the data tables are more or less the same. Over here we can see that I've added the unit. The unit was missed off here, so I'm just adding a few little bits. It's important to put the units down there. Everything else is about the same on each side, and the tables are very well organized. You can see we've got the 3 columns for the 3 trials. We've got the overarching column header here for potential difference with the unit and the average values here. So those are fine. Let's move down to take a look at the graph on both sides. There we go. So there's a few differences with the graphs, and I'm just going to sort of expand on the right one in a second. The left one here, we can see that the graphs, okay, the data points are plotted reasonably. There's a couple of problems. Units been missed off here. We can see that the graphs have been plotted by connecting the data points. We should always not connect the data points, and we should add trend lines. Trend lines have been added, you can see we have a linear straight line trend line here for the resistor data. Here we also have a linear one for the bulb data, and it's certainly not a straight line, so we shouldn't be putting a linear best fit line there. Also, the chart, the plot area, I think it's called, has not really been formatted, and it doesn't really look like a piece of graph paper. Let's take a look at the other one, which is worthy of a 7. So this one here, we have a key as well. We don't need the key for the linear resistor and linear light bulb. We can delete those. We've just got the key for the points, data points. We've got a nice curved trend line for the bulb data, and we've got a linear trend line there. This equation doesn't clearly say, but this equation relates to the linear trend line, which we achieved for the resistor. The plot area has been formatted so it looks like graph paper, and the axes are labeled with units. So that's a complete and nicely formatted graph over there. Let's put that back. Let's move on to the toughest bits down here, conclusion and evaluation. So let's take a look at the conclusion first. With the resistor, as the current increased, so did the voltage. However, they always remain proportional. Very important to state that. The voltage data with the resistor plots a straight line. This follows Ohm's law. With the light bulb, the increase in voltage was not completely proportional to the current, and the plot of the data is not a straight line. This is because in order for the bulb to light up, the filament must heat up, and as the temperature increases, so does the resistance. As a result, the current flowing through a filament lamp is not directly proportional to the voltage across it. So that's pretty good. I've just added a few things there, but this is not a bad conclusion. Reasons are given for the shape of the graphs. With the resistor, as the current increased, so did the voltage. However, they always remain proportional. The voltage data with the resistor plots a straight line through the origin. This follows Ohm's law, which states that the ratio of the PD to current remains constant for all values of PD. So I'm actually elaborating, I'm stating Ohm's law. The student mentioned Ohm's law, but I'm just stating it more completely. With the light bulb, it was not proportional, not even slightly, to the current, and the plot of the data is not a straight line, but a curve with an increasing slope, indicating that as the PD increases, the resistance increases too. This is because in order for the light bulb to light up, the filament must heat up, and as the temperature increases, the atoms vibrate more, and the electrons flowing through it find it increasingly hard to pass. So I've just gone into a little bit more depth there as to what's going on in terms of the on an atomic scale. Finally, we'll take a look at the evaluation. So this is a fairly basic evaluation. My circuit did not work at first as my light bulb was broken. Because of this, we lost time and we were not able to measure the potential difference when the current was 0.45 or 0.5 amps. Although this was not my fault, I did end up missing some of the data, which in the future I should try to avoid. Other than that, the lab went well. So I've elaborated on that. My circuit did not work at first as my light bulb was broken. Because of this, I lost time and was not able to measure the potential difference when the current was 0.45 or 0.5. Next time, I'd ensure that I had enough time to take data over a wider range of values, maybe up to 1 amp. This would allow me to make sure that the pattern I saw continued beyond the range of 0 to 0.3 amps. So the student is now suggesting that they increase the range of values to ensure that the pattern continues beyond the range that they've experimented on. So this breaks down into a problem and a suggested improvement. That's what we should always look at, including a problem with a suggested improvement. Let's look at the second one I've put down here. The value of current and PD fluctuated on the digital meters that we used, so it was hard to know what value to record. That's a problem we have with digital meters, the numbers jump around. To improve this, I could use vernier data logging sensors and record the current and potential difference for several seconds and take an average value using the Logger Pro software. So here's a very clear problem which is outlined and a very clear improvement suggested. So in your evaluation, look to do that. Find 2 problems or maybe 3 problems and suggest 2 or 3 improvements based on those problems. So as we can see, there's not a huge difference between these two reports. They're structured very similarly. It's just detail, including more scientific detail, more analysis, and more attention to detail as well in terms of data tables and graphs.